So this follows pretty directly. The ones that are doing A subtract 2. Yeah, don't think that would mess you up. But let's see, maybe on to this, the exponent next. This might be a fairly attractive place to make an error. 36 subtract and 6 squared is what we do next, right? Yeah, so that's one that might be kind of attractive, like me driving down the hill. Divide first. So the answer is 36 subtract 6. The answer is 30. Are you with me?
Oh, yeah.
So what's the attractive thing that you could do? That
Very nothing
36
attractive
minus
than that.
36 is 0. 0 divided by 6 is 0.
Subtract 36 to
Wrong.
36. Where did
Wrong
I get
answer.
36 subtract 6? Am I fucking lost?
So that's the point I was trying to make. That I don't think that one over there that we did before, I don't think that was tempting you into error as much as this one. So you need to practice enough to make sure you get over that of not being drawn into an error. Okay, let's see. What else? What's that last point for here? In section 3 is evaluate a... Oh, there are 2 more points. Let's see if I can speed this up here.
Great Scott. Just want to get down.
Very
I
attractive.
figure that for the kind of stuff that it sounds like that you keep messing with, that as well as the number stuff that we've already covered this evening, this is a big error. Area, not error. It's formula. Somebody gives you the formula for something you have to fill in for the particular place that you're, the particular data that you're using it. To evaluate a formula, on page 39, it talks about it. Read the book. Formulas are procedures. So you have a formula for the automotive. Even in welding, you might have the formula for area, the formula for the area of a triangle, the various formulas for different places. A formula is something that's got letters in it. And they do run over here on page 39 a little bit of geometric idea, that parallelogram, rectangle, square. So when they're given like that, you should run over and be familiar with them, the geometric things. And some formulas on page 40 for the perimeter of these figures. And the perimeter as you go along, let's see, we're going to do area also. This is pretty big applications. Is there a difference between perimeter and area? Yeah, there is. And it amazes me that some people cannot seem to keep those straight. Maybe none of you. But just a simple figure here. This is called a rectangle, right? And usually we call the longer dimension the length and the shorter dimension the width. Just in a sense that most people would do that. And so the perimeter of that is what? 2W plus 2L, which is the same thing, this order of operation, 2L plus 2W, whatever, it doesn't make any difference.
Really?
And so you might have a formula like that. And what's the area of a rectangle, though? Area, A, makes sense.
Length times
L,
width.
W. Now think about it. Here you've got two, this has units, whether it be feet, meters, or whatever. So this is going to be just in units, right? But this is units times units. So if it's centimeters times centimeters, you're going to get square centimeters.
Yeah.
Which you could write out, or you could use the exponent as handy like that, right? So that's, it goes over that, and there's a bunch of practice here. And if Mr. Zahner, I expect he is too, if you say to the problem, the answer, Mr. Zahner, is 328 feet, and it's supposed to be square feet, I don't even give partial credit. Now, I'm not sure about him. When I say, you missed the point.
You never
It
know.
was 328 square feet. And I don't even see counting half right, but I'm not sure. Dimension analysis sounds sophisticated, but it's somewhat what I'm talking about there. It talks about on page 43. And it gives various formulas. He may allow you some formula sheet on testing. He'll tell you about that too, as to how much he wants you to memorize on formulas. But if you have a formula, I'm pretty sure that one of the things to evaluate, do you know what this one means? I don't see that right there. You know what that means? It's the area of a triangle. So if somebody says, okay, the base is 2 inches and the height is 5 inches, you would be expected to put those in here and find out that the area is 1/2 times 2 times 5, which is 5, right? And as a side issue, do you remember, I just want to go on a really associativity, you do 2 times 5 is 10, half of 10 is 5, or you should learn to see there too. Mechanics of by hand. Okay. So that's something of an issue there. Perimeter and area, I'm looking at the exercise set now on page 47, 48. There are various ones with perimeter and area, a little bit of volume. Because the volume, of course, the volume is a 3-dimensional. So volume of a box, say, which is actually called a parallel pipe bed. That's interesting, but a box is what you would usually think. Length times width times length. So you've got so many inches times so many inches times so many inches. So you're going to get
a whole lot of
cubic inches. Now, so for instance, to deal with this room, if you were going to have to do what? If you were going to have to, for some reason, paint the, not paint. Let's see, if you had to put a strip along the edge, you would need just units, right? Maybe feet,
just
meters,
feet.
whatever. If you were going to have to put the floor in, you would need
Start from the middle.
square feet. If you wanted to know about the airspace in here, you would have to use cubic feet. Now, we've looked at powers. You could have the 4th power or something, and you might talk about the 4th dimension, the 5th dimension, but we live pretty much in 3 dimensions. And if you can do that, you could talk about the higher powers if you need to, but you definitely need the 3-dimensional idea. And the 2 dimensions probably more than the 3, but a heating and air person has to talk about, the volume of circulation too, don't they? And other places you might have to also. Okay, the last point here.
Yes.
And I'm pretty much on target of what I thought I would do and what I think I'm kind of hinted that I would be finished by 9 o'clock. I'm not sure you will.
Come on now.
You'll have to talk to Mrs. Long.
Got 6 minutes.
But the last point here is problems, and I want you to try one for me, and we will see how this goes.
He'd be shaking
Number, let's see, which one do I want to do? I think number 65. Yeah. This is page 49.
What?
It's almost time for happy hour.
Page
What's past?
49. Number
65. Oh, that's it.
65.
Recent years, 21,900,000.
This book is built for business too, so the
21,000.
US means business. So they have various applications in here.
Where the hell we at?
This one, all 4 of those in that set of BUS.
Bus. School bus.
And the CON, I think, means construction. So some of this stuff a carpenter might need, right? As far as building stuff. Various needs of the man.
It's a con.
So basic problems, verbally stated problems in different areas. To be able to read and think out what you have to do and American Communications. Again, an acronym. You might have your pencil and paper like he says on his notes there, so that you can write down and see. It seems like the process is helpful. We talked tonight about reading that number, right? Annual payroll, more than $5 million.
you
The
at?
dollar is important.
I'm
too. It's actually
65.
good. And yeah, I saw somebody within the last year put the dollar sign at the right side of the number. I don't know where they got that. So we usually put the dollar sign at the left side of the number, right?
Uh-huh.
214
Foreman.
employees. Average
Somebody figured this out so we can go home.
salary is salary would be dollars, and that must be what kind of operation are we doing?
Division.
Division, and the answer is
$26,178.44.
Out of 5 million? What the fuck? That sounds like a McDonald's payroll.
44 cents. And so when you're doing money, unless it says otherwise, I don't think you did there. You would usually stop